Hi everybody, Mr. Hassan here with the next lesson in our flipped classroom unit. Today we're going to be covering lesson 6.4, transform units, on page 233 of our textbook. So again, this is lesson 6.4, transform units, on page 233 in our textbooks. I'm going to refocus the camera. I'll see you guys in a minute.
I saw these fruit by the foot, or fruit by the feet, maybe fruits by the foot. Anyway, I figured they had mathematical potential, so I decided to just record myself playing with them. The first thing that comes to mind when there's a strip of paper, even paper covered in fruit-flavored sugar, is to make a mobius strip, so I did. Thing about mobius strips is they have one side, while fruits by the foot are by nature two-sided. A normal loop would have a paper side and a sugar side. Putting a half twist in would make a sudden transition from one to the other. But you can also do this. Wrap it around twice so the sugary part sticks to itself and the entire outside is covered in paper. Here's our mobius strip. After confirming that Sharpie flip chart markers won't bleed through the paper, I drew a line along the single side of the mobius strip, but that's not telling us anything that we didn't already know. Just like one line can cover both sides, except really one side, the paper does too. So unlike a normal loop of fruit by the foot covered in paper, which would need two pieces, one for each side, the mobius strip can be unwrapped by pulling off a single strip of paper. I went and washed the Sharpie off my hands and then came back to see what else I could do. The strip of fruit-flavored gunk has these two lines going down it, perforations dividing it into thirds. One of the go-to mobius strip fun things is to cut it in half down the middle, but after that, cutting it into thirds is the next thing to do, and it's as if fruit by the foot is designed for this purpose. So I started separating it along this line. You might want to pause here and think about what you think would happen.
Okay, so here we are at Unlock the Problem. A car's gas mileage is the average distance the car can travel on 1 gallon of gas. Maria's car has a gas mileage of 20 miles per gallon. How many miles can Maria travel on 9 gallons? Let's look at the little green box first. It says, would you expect the answer to be greater or less than 20 miles? Why? Well, I would expect it to be greater than. Because she can travel 20 miles on 1 gallon. All right, let's take a look at step 1 here. Analyze the units in the problem. Identify the units. You know two quantities, the car's gas mileage and the amount of gas. Gas mileage, she gets 20 miles per gallon. So another way to write that is 20 miles over 1 gallon. So the amount of gas that she would get would be 9. They want to know how far she can go in 9 gallons. You want to know a third quantity, the distance the car can travel. So we want to know the distance in miles. Let's take a look at step 2. Slide the book up here a little bit. There we go. All right, step 2 says, determine the relationship among the units. Think. The answer needs to have units of miles. If I multiply 20 miles over 1 gallon by 9 gallons, I can divide out units of gallons. The product will have units of blank, which is what I want, miles. The product's going to have units of miles. And so they show you exactly what they just said in that sentence in step 3. You're going to take 20 miles over 1 gallon and multiply that by 9 gallons. Now the nice thing is, if you remember from previous years when we talked about fractions, you can put anything over 1 and it stays the same. So 9 gallons over 1 still equals 9 gallons. And that's what they did here. They did 20 miles over 1 gallon times 9 gallons, and then they put that over 1. The gallons cancel each other out, and I'm left with 20 miles times 9, which equals 180 miles. So Maria can travel 180 miles on 9 gallons of gas. Number 1 says explain. Explain why the units of gallons are crossed out in the multiplication step above. And the reason that they can be crossed out is because we are simplifying. We're simplifying by dividing out those gallons. So we are simplifying by dividing out the gallons. Okay, I'm going to turn the page to page 234. I'll see you guys in a minute.
So I continue around, and when I loop around once, now I'm on the other side, and it turns out to not have been 2 lines, but 1 line that goes around twice. Let's see what we've got. It's completely whoa. I mean, this is totally magical to me that there's these 2 loops, and they're linked together, and they're not even the same size, and they're like made of flavored sugar gunk. But let's understand what's going on. You can do it with paper too. I cut out a strip, twist, and tape. Now I'm coloring the edge, both to demonstrate that the mobius strip only has 1 edge, and so that we can keep track of it. Because when we cut a strip into thirds, you could also think of it like this. You're cutting the edge off. This leaves a thinner mobius strip and a long looping edge. Because of the twist, the edge loops around the body of the mobius strip, so the 2 are linked. Really though, you should just try it yourself. After making a mobius strip and ripping it into thirds, I poked at the leftover bit of fruit by the foot, waiting to be inspired. I don't know, it's spirally? I opened up another package so I'd have more to play with. Bam! Whoa! It's got this pattern on it. I mean, I don't remember this at all about fruit by the foot, but then again, it's not like I've had one in the past like 15 years. And last time I had a fruit by the foot, I wouldn't have recognized that this is a freeze pattern. A symmetric pattern that repeats in 1 dimension. I mean, repeating patterns are good because they have a rolling stamp that just kind of presses this pattern into it. But it's got other symmetry too. The 2 halves of this pattern are exactly the same, but not the same as in mirror symmetry going the long way. But it does have mirror symmetry going the short way, plus this point of 180-degree rotational symmetry, which basically means if you turn this strip of fruit roll up around, the pattern is the same. But it's neat that it does this in 2 tessellating halves, so you can flip it around and fold it in half and everything.
Okay, so here we are on page 234. Sometimes you may need to convert units before solving a problem. Example, the materials for a rectangular awning has an area of 315 square feet. If the width of the material is 5 yards, what is the length of the material in feet? Recall that the area of a rectangle is equal to length times its width. You know 2 quantities. Step 1, identify the units. You know 2 quantities, the area of the material and the width of the material. Area is equal to 315 square feet. So the width is going to be 5 yards. Right? The width, up here we can look at the problem, it says the width of the material is 5 yards. You want to know a third quantity, the length of the material. We're looking for the length. The thing is, look at this problem. They're giving us the width in yards, the answer's in feet, and they want the length in feet. So we're going to have to be really careful here because I have a feeling in the next step we might need to convert the width that's in yards to feet so that we can solve this problem. Let's take a look at step 2 and see if I'm correct. I'm going to slide the book up here a little bit. All right, step 2. Determine the relationship among the units. Think. The answer needs to have units of feet, so I should convert the width from yards to feet. Boy, I'll tell you, sometimes it's like I can see the future. If only I could do that with the lottery. Oh well, let's take a look at what they did. So here's the width. The width came in yards, so they did 5 yards over 1 times. Now they're going to use conversion factors like we talked about in the first 3 sections. They're converting yards to feet. We know that there are 3 feet in every 1 yard. Yards can cancel each other out. 5 times 3 feet gives me 15 feet. So if I divide the area by the width, I can divide out the units of feet. That's what we did here. The quotient will have units of feet, which is what I want. Step 3, use the relationship. Divide the area by the width. 315 square feet divided by the width of feet is 5. Write the division using a fraction bar. So it's going to be 315 square feet over 15 feet. And then write the units of area as a product and divide out the common units. So 315 feet divided by 15 feet times feet. Feet cancel each other out, and now I've got 315 over 15. If I do that division, you can put it into your calculators, and the answer is going to be 21 feet. So the length of the material is 21 feet. All right. Now, I personally don't like the way the textbook solves this problem. I think they make it more difficult than it has to be. The way that I would solve this problem is I know, I'm going to solve it over here using a different method. So I know that area of a rectangle is equal to length times width. They give us the area, that was 315 square feet, is equal to, they don't give us the length, so I'm going to leave that L, and I'm going to multiply by my width, and my width is 5 yards, which we converted to 15 feet. And I'm going to solve this just like I would solve a basic equation problem. I'm going to divide both sides by 15 feet. Bring down my equal sign. Now my 15 feet cancel each other out. I'm left with my L, which is my length, and my length equals, and here it's just like the same problem we did down here. 315 divided by 15 gives me 21, and then feet squared divided by feet gives me feet. So my length is equal to 21 feet. All right, let's look at number 2. I'm going to slide the book up here a little bit. Number 2 says, explain how knowing how to find the area of a rectangle could help you solve the problem above. Well, if you know how to solve the area of a rectangle, then all you have to do is search for the missing variable using algebra, like I did above. Another way to do it to find the area of a rectangle is multiply the length and width. If the area and the width are known, you can divide to find the length. So either way is acceptable here. We could do it the way the textbook did, which was dividing by the width, or you could set yourself up an equation like I did. So the second time, so I'm going to slide the book up here. So the first time, all they did was they set their problem up here, and then they divided out their feet. They divided out their feet here to get feet. I think mine's a little bit easier to see. So when I answer number 2, I'm going to write by using the formula for area, I can solve for length. Let's look at number 3. Number 3 says, explain why the answer is in feet even though the units are divided out. Well, and that comes back up here, right? So let's take a look at this. Here's where I'm dividing. So what they're asking you is, why aren't they in square feet? Why are they in feet? And that's because feet times feet would equal squared feet. And squared feet divided by feet would equal feet. Think about it this way. If I have 2 times 2, that's going to equal, well, yeah, everybody's saying 4, but it could also equal 2 squared. So if 2 times 2 equals 2 squared, doesn't feet times feet equal feet squared, or square feet? Absolutely. And then can't I also say that 2 squared divided by 2 is equal to 2? And I could say the opposite. I could say that feet squared divided by feet would give me feet. And that's what they're asking here in number 3. Explain why the answer is in feet even though the units of feet are divided out. Because you weren't actually dividing feet by feet, you were dividing squared feet by feet. And that's the answer. Because you were dividing squared feet by feet. And hopefully you understood what the heck I was just talking about. Either way, I'm moving on to page 235. I'll see you guys in a second. All right, let's take a look at number 1 on page 235. Share and show. A dripping faucet leaks 12 gallons of water per day. How many gallons does the faucet leak in 6 days? Quantities you know. 12 gallons for 1 day, and they want to know that this takes 6 days. Quantity you want to know. You want to know gallons. That's what you're trying to figure out. So if you leak 12 gallons per day, we're going to multiply that by 6 days. The days cancel each other out, and so we've got 12 times 6, which equals 72. 72 what? 72 gallons. So the faucet leaks 72 gallons in 6 days. All right, let's look at number 2. Number 2 says, bananas sell for 44 cents per pound. How much will 7 pounds of bananas cost? Again, this is going to be another multiplication problem. I need to figure out, I need to use the rate of 0.44 dollars per 1 pound. And I want to multiply that by 7 pounds. Pounds are going to cancel each other out, and I'm going to have 0.44 times 7, which is going to give me, I'm going to punch this into my calculator, and I get $3.08. So that would be my bill for my bananas. $3.08 for 7 pounds of bananas. That actually sounds like a pretty good deal. I'd probably buy the bananas at 44 cents a pound. All right, number 3. Grizzly Park is a rectangular park with an area of 24 square miles. The park is 3 miles wide. What is the length in miles? So here, I need to know the formula area equals length times width. They give me the area, so I'm going to fill in that. 24 square miles is equal to, do they give us the length or the width? They give us the width is 3, so I'm going to keep my L times my 3 miles width. So I've got 24 miles equals L times 3. Well, I want to get rid of the times 3 so I can get L all by itself. So I'm going to divide this side by 3 miles, and I'm going to divide this side by 3 miles, and I'm running out of room here, so I'm going to come over here. My 3 miles cancel out. I'm left with L here, and then 24 divided by 3 gives me 8 miles. So my length is equal to 8 miles. Okay. All right, on your own. On your own here. It says, I just hit the book. Sorry about that. On your own, multiply or divide the quantities. Here for number 4, I've got 24 kilograms over 1 minute times 15 minutes. So it looks like my minutes are going to cancel out here, and I'm going to be left with 24 kilograms times 15, and that gives me, I'm going to punch it into my calculator, and I get 360 kilograms. Number 5, 216 square centimeters divided by 8 centimeters. This goes back to the previous page, to when we were talking about dividing square centimeters by centimeters, or anything that's squared by something that's not squared. It's going to cancel out that squared, and we're just going to be left with centimeters. And if we reverse this problem, we would have centimeters times centimeters, which would give me square centimeters. So it makes sense that square centimeters divided by centimeters would give me centimeters. Now I just have to divide my numbers. 216 divided by 8 equals 27 centimeters. All right, number 6. 17 liters per 1 hour times 9 hours. Again, my hours cancel each other out. I've got 17 times 9, and that's going to give me 153 liters. I love how my calculator makes noises like that. It's so cool. Don't be jealous. All right. Number 7. It says, a bamboo plant grew at a rate of 16 inches per day. How many inches did it grow in 8 days? So if it grows 16 inches per day, we need to find out how much it grew in 8 days. So my days cancel out. I'm left with 16 inches times 8. And hang on, let me get my calculator. And my answer is 128 inches. Let's look at number 8. Number 8 says, Orlando's new hybrid car gets 45 miles per gallon. How many gallons of gas did he use to drive 180 miles? Now this one's a little bit different. This one we can't really use our unit rate to find the answer because we're going to end up not being able to cancel our gallons or our miles out. I think it's easier to use a ratio to solve this problem. And watch what I mean. So he goes 45 miles in 1 gallon. They want to know how many gallons or X gallons will he get in 180 miles. So for this problem, to solve this problem, we need to find out how many times 45 can go into 180. We need to find out how they got to 180 here. And so if I divide 180 by 45, I'm going to find out this X value and find out how many times or how many gallons I end up getting. And the answer is going to be 4 gallons. The other way to solve this would be to cross multiply. You could cross multiply and get 45x. And then on this side, you'd get 180 times 1 would be 180 gallons. And then again, you would just divide both sides by 45. My 45s would cancel, and I would have x equals 180 divided by 45 would give me 4 gallons. My x right there. All right, that's going to be the end of our lesson today. I hope you enjoyed it. I'll see you next week for lesson 6.5. Mr. Hassan signing out.
Okay, so I opened the last of my fruits by the foot, hoping for another freeze pattern, but it's the same as the last one, so I make a normal non-mobius loop, and then I make a couple more and decide to put them together in a Baromean configuration. The Baromean rings are this arrangement of 3 loops that you see sometimes, and they're linked in such a way that no 2 loops are actually linked with each other. I mean, if you look at just 2 of the 3, they're not linked. If you undid any one loop, the other 2 would also be separated. Yet the 3 together are stuck. I tightened the loops up because they form this nice wrappy cube, and then I decided to try taking off the paper, but it was tricky because everything's sticky and linky, so it didn't turn out so well. So since I'm labeling things, I labeled the mobius strip part. And that reminds me that the freeze patterns and mobius strips are related. At least this particular freeze pattern has, as a result of its other symmetries, glide reflection symmetry. And glide reflection symmetry means that a pattern can be mobius stripped. See, when I loop it around into a mobius strip, the pattern exactly matches up, even though it's upside down. Oh, glide reflections. The glide is the loop part, and the reflect is the flip part. And what that means is that, with just 1/2 of this nice tessellating pattern, we can loop it with a twist and it matches up perfectly with itself to make a complete strip. At least, theoretically. In practice, it's a rather sticky process.
Dance with me, I want to be your partner, can't you see? The music is just starting, night is gone.